There's a lot more information to address now that Baz has cooked up another excellent version of the Walensky-Taylor diagram. But before I address a lot of it, I want you guys to see it for yourself. I'll link this paper to the bottom. It looks very organic, really curvy. I like curvy things. Curvy things make it, will put your mind in a place to where you can sort of imagine it actually happening. It's a bit uncommon to see in nature things that are straight, or rectilinear is the word for it. Like when trees grow, they grow in curves, branches grow in curves. The earth is curved, it's not flat, that kind of stuff. This paper is Stellar Metamorphosis. Where are the stars Earth orbited in the past? The abstract goes, Earth did not always orbit the sun because the sun is at least 100 times younger than the Earth. So the question arises, where are all the stars Earth used to orbit if the sun was not always in the picture? The reader will realize in this paper the sun is a foster host, as were many others. As well, we are dealing with a solar system that has a deep, deep history and a certain strangeness that is now addressed with clarity. I'm not going to read this out completely, but I will review something very interesting that I've noticed. There's some electrostatic right here on the thought that was pretty cool. Okay, anyways, Io, or any small rocky world, for example, I would say Io would be about right there, about 1 billion years old, and below the Earth in mass, far below the Earth in mass, and near the same phase curve as Neptune. With that being said, Earth, I'll let you guys read the paper yourself and just sort of absorb the information. Earth is very old. I would say about 10 billion years old, at least. I know astronomers say it's 4.5 billion. I think it's at least double that. But if Earth was around for 10 billion years, and the sun was around only for about 90 to 100 million years, 120 million years, the Earth had to have something else to orbit. And that being said, if you have objects that evolve like this, then it means even objects like Neptune or gray dwarfs or Jupiters were very big and very hot in their past, in Earth's recent history. So you would have objects that say are right there where the gray dwarf is. And to make it up to Jupiter, which I think is about 550 million years old, you'd only have to move about 450 million years from here to here. But 450 million years from here to here is maybe just a little, like 3 or 4 millimeters to the what would that be, to the left. And that being said, these stars are very young and they evolved very fast. So the objects that Earth orbited in the past, for 90% of the time, is missing if it's supposed to be a really hot young star. You see, 90% of the time, and I have this in the paper, the Earth was probably orbiting something currently is highly evolved itself, probably down here below gray dwarfs and all the way to ocean world stages. And that's strictly because it takes so long for these objects to evolve. The other objects sort of play catch up as the Earth is evolving. And that's very weird to think about the solar system like that. But it's also very powerful in that it gives you a different perspective. It means that if an object like Io, and this is my example, if an object moves down the transformation curve extremely fast, it could be both much, much younger than the Earth by billions of years, be smaller than the Earth by many Earth mass, or by many of itself mass, not Earth masses, because then it wouldn't exist. they could be a lot smaller, and it could have been at one point a much younger, hotter object when the Earth was orbiting. So it means not only should we look at Earth possibly having orbited Jupiter or Saturn, which are a few hundreds of millions of years old, but we can look at objects that are about 1 billion, 2 billion, that are much smaller than the Earth, as long as you have them having orbited a much younger, hotter host, which ripped it apart long before it could become something like the Earth itself. So when you look at Io, when you look at Ganymede, when you look at Titan, when you look at these objects, keep in mind they might be younger than the Earth. Don't just look at them, oh, well, Mercury is older than the Earth, clearly. But don't look at it as it being they're smaller, therefore they're older. Because that's not necessarily true. Because they could have been ripped apart a lot earlier in their history, and they could just fly down what Baz and I consider to be the Bolt transformation curve. Of course, Bolt meaning Usain Bolt. It's the transformation curve where this object evolves extremely fast. So it's very weird to think about it like that. Earth orbiting Io? It doesn't make any sense, because Io's a lot less massive than the Earth, and Io currently orbits Jupiter. Well, clearly, but then you have a lot of other things involved too, because when you remove the mass from objects, from stars quickly, it causes those systems to go into chaos. So this is a very chaotic process, which means a lot of the objects the Earth possibly orbited in the past aren't even in the solar system anymore. Not only that, but the solar system itself didn't exist as it currently is 100 million years ago, because the sun wasn't even in the picture yet. So to understand the solar system, you also have to look at the fact that maybe Jupiter, Neptune, Saturn, they weren't anywhere near each other. They had their own systems themselves, and it evolved greatly on their own time frames. And then further on to their evolutionary history, where a lot of their past history has dissipated back into space due to mass loss, then the sun came in the picture and then gave the appearance of the solar system as it is now. And it's very different to look at the solar system like that. And I'll go into this real quick just to show everybody what I mean. I went to a book sale today at the library, and I found this stele. Check it out. This thing, really, really great book. It goes over the history of about 500 years of figuring out how telescopes came to be, who was using them the most, a lot of history, a lot of old documents in here. It's very, very interesting looking at this. But besides this book, this was 1981 was the copyright date, December 31st, 1981. And I found this little pamphlet, this little National Geographic pamphlet inside the front cover of this book. I was like, what the heck? This is National Geographic. This isn't a National Geographic book. So somebody must have put this in here as well. This little graph here is dated August 1990. So it might be about the same time. Somebody must have just stuck it in there, but this is pretty new. And I just wanted to show you guys where the mindset was back in 1990. Of course, this is 29 years ago. I was 5 years old. Portraits of the Celestial Family. You can pause that to read it if you want, but I'll read it right now. So varied are the faces in this portrait gallery of planets that it is hard to imagine they belong to the same family. Yet family they are, born of common cosmic material and brought in by gravity to our sun. Let me repeat that. So varied are the faces in this portrait gallery of planets that it is hard to imagine they belong to the same family. It is hard to imagine because it's not true. These objects, go ahead and open this up for you. These objects, Jupiter, Saturn, Uranus, Neptune, and you have, what's that? Earth, Venus, Mercury up there, and Mars. It's hard to imagine they belong to the same family because they look so different. And intuitively, that's the conclusion astronomers should have been making from the very beginning, is that they're not a part of the same family, that they are very, very different, that they all have different evolutionary histories, and that they all are vastly different in age and are in their own stages of evolution. We have a adopted family full of objects, grandpas, siblings, I wouldn't say siblings, I guess distant cousins. But we don't have a nuclear family here. We don't have a mother, we don't have a father, we don't have brothers and sisters. We have objects that are related cosmically, but on a much grander scale. It's a foster family, I guess you could say. It's an adopted family full of objects that are all different. And they're not all born from the cosmic or common cosmic material, born of common cosmic material. That's the assumption that it all came from the sun's leftover material. But as in this paper, it's made clear that it would be impossible for them to be of the same common material, from the sun. The sun is the baby of this family. So we have to kind of look at how these objects evolved and then stretch your mind to places where establishment they can't go because they're all trying to force them to be the same age. 4.5 billion years. All right, guys, I'll go ahead and link this to the bottom and you guys can read it for yourself. Today is April 7th, 2019.